we have momentum to contend with today. Momentum is a fundamentally important quantity. We regard it as the quantity of motion, and so now we're going to spend some time and get comfortable with it. A couple things. Momentum is a vector, don't forget that, okay? That when we think about the momentum, we can change the momentum by changing the mass of our object, but also the velocity. Okay, so not just the magnitude of the velocity or the speed, but its direction as well. So an outside influence can change the momentum, just like an outside influence can change the velocity. So we quantify this idea that if we have a force, an external force to an object, it can impart an impulse onto an object. Let me say that again. It can impart an impulse. That really means changing the momentum. So the impulse quantifies the change in the momentum. Okay? So as an example, take a look at this slide. Okay? In the top here we have a golf ball being hit by a golf club. The ball is our system, the golf club is external. So the ball starts with no initial momentum, zero initial momentum. And when the golf club exerts a force, it imparts an impulse. It changes the momentum so that the final momentum is different than where it began. Similarly, we can think about what somebody, in this, so this figure is a little goofy, but this is a person heading a soccer ball. The ball is our system. The guy's head is external. And so the initial momentum, in this case, is not zero. When the person heads the ball, he imparts an impulse. And as a result, the momentum of the ball changes. This vector diagram shows this idea that J represents the change in the momentum, or the impulse is the change in the momentum. Now, the other thing that's important here is that impulse is related to how the force acts over a certain time interval. So we talked about Newton's second law, right? So Newton 2 tells us that the net force acting on an object is the mass times the acceleration. Now that's okay, but it's a little better if we call this the mass times the change in the velocity over some time interval. Now I can do a little algebra here. Okay? If I bring the mass inside of here, what I really get is I get that a net force changes the momentum of an object in some time interval. Momentum becomes our quantity of motion, and further, and importantly, if I rearrange this a little bit, what I find is that my change in my momentum, which is the impulse imparted by, in this case, the net force, well, if I rearrange this, this is just the net force acting over some time interval. Okay. So this expression here tells us that it's the force, but it's also the time interval over which it acts. As an example, imagine a soccer ball being kicked by a foot. The ball is our system. The foot and the force it exerts is external. Now, our expressions typically deal with constant forces. But if the force is not constant, then if I were to plot the force versus time, the area under the curve gives us our impulse. And so in this particular figure here, we can see that the contact begins, and then the force is zero, and then the contact begins. Force increases. There's a point of maximum compression where the force of the foot is largest. And then as the ball compresses and then leaves the foot, that force goes down, and eventually contact ends. So the force is not constant, but if we take the area under the curve, that gives us the impulse. Do example 9.3. It's a really good one. But this idea of impulse being, if a constant force acts, the constant force times delta t. Or, it's a varying force, it's the area under the curve. That idea is important, and it's going to lead to a lot of problem-solving strategies for us. Have fun. Come chat.